Hello everyone, this is Professor Ng Chi Kun from Unimas. In this video, I'm going to give you a tutorial solution on approximate analysis of statically indeterminate frame with lateral loads using cantilever method. So in this tutorial question, we have a frames A through L, and then use the cantilever method and determine approximately the reactions at the supports A, B, C, and D. So all the columns have the same cross-sectional area, so meaning that the columns at A, B, C, and D have the same cross-sectional area. So to start, we are going to put hinges at the middle of the columns, at the center of the columns and girders. So in this case, we need additional markings for the hinges. So we will put additional markings as we go along. No? So in this case, for the first part of the analysis, we will have to detach this frame away from these hinges here. So the first free body diagram that we have looks like this. So the additional marking that we put in is M here, O here, Q here, and S over here. So for every hinge, or for every hinge that we put in, we have to put in the unknown forces. Okay, so for hinges, we know that they are all zero force points. So in this case, we only have a horizontal force and also a vertical force that are unknown. So we take this point as M, this point as O, this point as Q, and this point as S. So each point will have two unknown forces with the markings as shown. And then we know that these columns have the same cross section. So the centroid of the column, of the group of columns, will be at the center of the group of columns here. And then we know that the stress or force in the column is proportional to the centroid. So we just draw a line from the centroid slanting downward like that, and then we just draw another line here slanting downward like that. And then we know that the force in the column on this side will be in tension, so we put tension, unknown force there. And then the columns on this side will be in compression, so we put in compression, unknown force for these columns there. And then we have a 9 kilonewton force going from left to right. So the unknown forces in the hinges, we just put it from right to left for equilibrium purposes. So all these are unknown forces, mx, my, or x or y, qx, qy, and sx and sy. They are all unknown forces. So first of all, we want to sum moment about the centroid of the columns over here. So if we sum moment there, and by taking counterclockwise moment as positive, so we have my times 7.5 meters, and then we have oy times 2.5 meters, and then we have qy times 2.5 meters, and then we have sy times 7.5 meters. So these are all positive moments because they are all anti-clockwise moment with respect to this point. And then the last force that we look at is this 9 kilonewton force with moment out of 2 meters, and this is creating a clockwise moment, so clockwise moment is minus 9 times 2. So there is no other forces producing moment about this point here, so we equate this to 0. Because Sx, Qx, Ox and Mx, they all passes through this point here, so no moment created by these horizontal components of force Mx, Ox, Qx and Sx. So with this equation we have 4 unknowns. So we need 3 additional equations so that we can solve for all the unknowns. So in this case, the first equation that we can look at may be solved from this similar triangle here. So we can take my over 7.5 is equals to Oy over 2.5 as depicted here. So my is 3 Oy, so meaning that my is 3 times of Oy. The next equation that we may look at is from this similar triangle here and here. So from these two similar triangles, we have Sy over 7.5 equals to Qy over 2.5. So meaning that Sy is equal to 3 Qy. And then another equation that we may look at is these two similar triangles, right? So here we have Oy over 2.5 is equals to Qy over 2.5. So Oy is equals to Qy. Okay, so this will be equal in magnitude. Okay, so these 3 additional equations, you just substitute all these into these equations here, then you can solve for all the unknowns. Okay, so here we get Oy equals to Qy equals to 0.36, and then my is 3 Oy, so this is 1.08 kilonewton. Okay, so next we move on to another free body diagram that we detach from the frame at this hinge here, this hinge here, this hinge here, and this hinge there, and then isolate the top part of the building frame as a free body diagram. So we have point T, V, X and Z here. So for every hinge we have 2 unknown forces as depicted. So in this case we will also be summing the forces at the centroid of the group of columns here. So in this case, when we sum moment, we always take anti-clockwise moment as positive. So we have Ty times 7.5 plus Vy times 2.5, By times 2.5 plus Xy times 2.5 plus Zy times 7.5, right? And then we have moments from these 2 forces here. So here we have 9 times 6, which is a clockwise moment, so negative. And then we have 12 times 2, also clockwise moment, so minus 12 times 2, and equals to 0. So similarly, we have 4 unknowns, so one equation is not able to solve for all the 4 unknowns, so we need 3 extra equations. So the 3 extra equations, first one will come from this similar triangle, So here we have Ty over 7.5 is equals to Vy over 2.5. So Ty is 3 Vy. The second equation is from this similar triangle. So we have Zy over 7.5 equals to Xy over 2.5. So Zy equals to 3xy. And then another equation comes from this triangle and this triangle. So they are similar. So Vy over 2.5 is equals to xy over 2.5. So Vy equals to xy in terms of magnitude. So by substituting all these equations into this particular equation here, we may solve that Vy or xy is equals to 1.56 kilonewton. So Vy and xy, they are all 1.56 kilonewton. Okay, and then Ty is 3 Vy, so Ty is 4.68 kilonewton. Zy is 3xy, so Zy is 4.68 kilonewton. So after that, we want to move on to solve for the other unknowns. We haven't solved for mx, ox, qx, and sx yet, and we haven't solved tx, vx, xx, and also zx yet. So next free body diagram is taken from here by taking the hinge over here. Okay, so we detach the hinge over here with 2.5 meters away from this point here. So we are getting this free body diagram, and we mark this point as N, right? So if we mark this point as N, then we have unknown force of Ny and an unknown force of Nx, and here we have already solved for My, so My is 1.08 kilonewton, and then we haven't solved for Mx yet. So in this free body diagram, we have three unknowns, and you can solve for these three unknowns using the three equilibrium equations. So you can try this out yourself, and the answers are already given. Similarly, if we look at point N here, and point J is there, and then we put in another point P there. So this is taken from here, okay? So this is point N, this is point P, and this is point O. Okay, so we detach this part of the structure away from the whole structure and isolate this as a free body diagram. So in this case, we have already known that this one is from the previous free body diagram here, point N. So the forces must be same magnitude and opposite of all these two Nx and Ny forces. So Nx is 7.65 kilonewton in this direction, and the Ny is 1.08 kilonewton in this direction. And just now we already solved Oy, which is equal to 0.36 kilonewton. So Ox, Py, and Px, there are three unknowns. Okay, there are three unknown forces. So with three unknown forces, with three equilibrium equations, you can also solve for Px, Py, and Ox using this free body diagram. So please do your own solution, and the answers are already given. So if you get the same answers, mean that you are doing it right. And then the next part is by taking a free body diagram like this. Okay, so this free body diagram is taken from here by detaching this hinge, and this hinge, and then isolate this part as a free body diagram. So we have a 12 kilonewton force acting at point E there. So we have 12 kilonewton force acting at point E, and then we have this point which is common to this point M here. Okay, so here we already got MX and MY. So the similar point, okay, of M in the other free body diagram must have complementary forces to these two forces. So My going down and Mx going from right to left. So Mx must be going up. My. My must be going up, and then Mx must be going from left to right, opposite of the previous free body diagram. And just now we have already solved for Ty. So Ty is 4.68 kilonewton, and then we don't know Tx yet. This one hasn't been solved yet. And then we have another hinge that we mark as point U. So over here we have an unknown force of Uy and unknown force of Ux. So with three unknowns and three equilibrium equations, then you can solve for Tx, Uy and Ux using sum of horizontal forces equal to 0, sum of vertical forces equal to 0, and sum at joint U equals to 0. So summing moment, you may use any points. Okay, but normally we will just sum moments at the point where you have two unknowns, so that you can solve for the other unknown, Tx. Right? So try this out on your own. See whether you can get all these answers right. Yeah. And then next, we move on to the segment of the frame of this joint here, the joint here, we detach another joint there, and then another joint there, and another joint there. So there must be hinges here and hinges here as well. Okay, so now we want to detach this joint, this joint, this joint, this joint, and isolate this as a free body diagram with the center joint here of joint F. Okay, joint F is at the center. So this point is W. We mark it as W. And then this joint here is joint O. So we put all the joint O forces by opposite direction into here. Okay, so joint O, just now we have 3.15 and 0.36. So 0.36 is going downward. So here 0.36 must go upward. And then just now the horizontal force of joint O is from right to left. So this one must be from left to right. Okay, so these are known forces. And this is taken from joint U. Okay, we have joint U here. So they are common joint. So this is the forces that we take from joint U but opposite direction. Okay, and then for joint V, just now we have already solved for Vy, which is equals to 1.56 kN, and Vx is not solved yet, so this becomes an unknown in this free body diagram. And this joint here, we also haven't solved for the forces, so we mark it as Wx for the horizontal unknown force, and mark it as Wy for the vertical unknown force of joint W here. So by using the three equilibrium equations also, you can solve for these three unknowns. Okay, so try it out for yourself. And then next, you want to move on to the column. Okay, so this is taken at joint. This joint is joint T. Okay, so we are taking this part of the structures. Okay, so this is joint T, so we detach hinge T and detach support A, and then we are going to get a free body diagram like this. Okay, so this is Ty and this is Tx. So Ty and Tx, in this case, we have 3.15 kilonewton from right to left, and this is downward. So in this case, this must be Tx from left to right, and this Ty is upward. They must be complementary to the joint T in the other free body diagram. And then when we detach the fixed support, there must be 3 reactions, 1 moment and 2 orthogonal forces, Ax, Ma and Ay. So Ma was assumed to be anticlockwise. Okay, so here we can also make use of the 3 equilibrium equations to solve for these 3 unknowns. So these are the solutions. So please try this out yourself as your own practice. So next, we move on to column that is fixed at joint B. So we detach this point here, okay, which is joint V here, okay, that is attached to the column that ends at support B. Yeah? So this is point V, okay, joint V. So joint V, we have Vx equals to 7.35 kilonewton and Vy equals to 1.56 kilonewton. So in this case, the 1.56 kilonewton must be upward. Just now in the other free body diagram it was downward, right? So this one must be upward. And then in the other free body diagram, okay, this force was from right to left. So in this case, it must be from left to right, opposite of the forces of the force direction in the previous free body diagram. And then when we detach away from joint B here, so joint B is a fixed joint. So fixed joint, we have 3 reactions, 2 orthogonal reactions and 1 bending moment. So by making use of the 3 equilibrium equations, we can also solve for Bx, By and Mb. So these are the solutions. Okay. And then we have to move on to the other part of the structures, which is free body diagram in T shape like this, where the internal joint here is joint K. So in this case, we are taking this part of the structure as a free body diagram, right? So in this case, this joint here, okay, is common to this joint here, joint P, okay, alright. So joint P, we have 4.5 kilonewton force in the horizontal direction, and Py is upward, equals to 1.44 kilonewton. So in the other free body diagram, okay, these forces must be opposite of the one that was in the other free body diagram, but is the same joint. Yeah? Okay, and then this one is OY. So OY just now has been solved, is a compression force of 0.36 kilonewton, and then we haven't solved for QX. So this is another joint where we don't know the internal forces. So we put it as joint R, and we have Rx and Ry. So from this free body diagram also, we have three unknowns. So with the three equilibrium equations, we can solve for these three unknowns. So please also do this as your own practice, and the answers has been given. So next we move on to the other part of the structures. Okay, so this is joint R. So from joint R here, you just take these forces and then put them here, but in the opposite direction. Okay, and then here is SY. So SY already been solved previously. It's 1.08 kilonewton of compressive force in the column, and then the shear force in the column of SX is an unknown. So here we just need one equation. So total forces in the horizontal direction equals 0, and you get Sx equals to 1.35 kilonewton. And then we take another free body diagram, okay, with the center fixed joint here of joint G. So we are taking this as a free body diagram. So please take note that this is a common joint with this free body diagram. This is a common joint with this free body diagram. So all the forces here and here has been determined from this free body diagram and this free body diagram. Okay, so left only this joint that we have unknown force, and so this joint for the shear in the column is not known yet. So what we can have is something like this. So this joint here, we already know the solution. This joint here, we have already known the solution. So here we have Rx, and here we have Ry. There's a mistake here. So this should be Ry. Okay. Okay. Or I think that is should be Y. Sorry. So this is correct. So this would be Y X. So we correct that. So this is Y X. Okay, so in this free body diagram here, the only unknown force is XX. XY has been determined from the previous solution, and then the other unknown is YX and YY. So with the three equilibrium equations, we have three unknowns here, so we can solve for these three unknowns using the three equilibrium equations as well. So next we move on to another part of the structures where this joint is Y. Okay, so this one we take it from the previous solution, YX and YY. So this is YX and YY, but in the opposite direction to this YX and YY. Okay, and then the only unknown here is ZX. Right? ZY has already been determined previously, so we have only one unknown here. So we solve for ZX. So next, we take the column segment that is connected to C, and this joint is the common joint to this joint here. Okay, joint X. right? So this is joint X, so this must be the forces from joint X. Okay, 7.35 kilonewton and 1.56 kilonewton. So 7.35 kilonewton and 1.56 kilonewton, but opposite to the joint X previously. Okay, opposite to this force directions. And then when you detach joint C away from the fixed joint here, there are 3 reactions. So with 3 reactions and 3 equilibrium equations, we can solve for the 3 unknown forces and moment. Okay, and also when we detach this joint jack and joint D, so this is joint jack, so joint Z is here, so these are ZX and ZY. So this is ZY, this is ZX, but in the opposite direction to the free body diagram before. And then if we detach joint D away from the fixed joint, there must be 3 reactions. So we have dx, dy, and unknown moment md. So using the 3 equilibrium equations, we may also solve for these 3 unknowns here. So that's all for this tutorial. Thank you very much for watching.